right, so we are going to take a moment to work this problem here. It says that we have a Mexican jumping bean, and it jumps with the aid of a small worm that lives inside of the bean. The bean jumps 0.015 meters from your hand into the air. What is the velocity of the bean as it lands back on your palm? So here we have a situation where we have an object. It's going to start from this position, so this becomes our ground level. So we have a height of 0 at this point. And then it says that it jumps to a height of 0.015 meters, okay? So it's asking what is the velocity of the bean when it returns to your hand. So we're going to return to a height of 0 meters. So for this question, we're actually going to have our height of 0.15 meters serve as our initial position, and then our height of 0 meters when it returns to my hand as our final position. So what is our energy transfer here? We are all potential energy at the highest point, and it is being transferred to kinetic energy at the lowest point. This is actually conservation of energy. So we're going to say PE plus KE initial equals PE plus KE final, where at the highest point, we do have some potential energy here. We have a 0 kinetic energy. Remember, at the highest point, that velocity is going to be 0 momentarily. So this kinetic energy will go away. At the lowest point, we would have a potential energy of 0 because we have a height of 0, and we would only have kinetic energy available. So this potential energy goes away. So in this particular case, I do not know what my initial potential energy is, so I will need to calculate that using mass times gravity times height. I do not know what my final kinetic energy is, so I would need to calculate that using 1/2 mv squared. If we look at our givens, I actually have them highlighted. We have an initial height of 0.015, and that's the only variable that they give us. So you may initially be thinking that you do not have enough information in order to perform this calculation, especially if you feel determined that you need to come up with an answer here before you can set it equal to the other side. Well, in this case, you cannot work this as a two-step problem. I have spoken with you about this on several occasions in the past. You do need to get comfortable with putting your formulas together to make one new complex equation, and that is the only way we can work this problem. What we're going to do in this particular case is see that our masses are actually going to cancel out. This is not an M1, M2 because there's two objects. This is the same M. It is the same object. So when we get ready to do our algebra, these two M's are going to cancel out. Regardless of what I'm solving for, I'm dividing both sides by M. So when I divide by M, these cancel, right? Those two masses are going to cancel out. And so that is going to simplify my equation to just be gravity times height is equal to 1/2 times velocity squared. I know gravity. They gave me height in the problem. 1/2 is just a number, and then I am just simply solving for my velocity. So I would simplify what I have over here, and then I would simply divide that by 1/2 or multiply both sides by 2, however you want to say that. So you're going to get some number here, and then we're going to square root that because that will be equal to v squared. And our final answer comes out to 0.54 meters per second. This is obviously just a made-up number. So whatever that number is would go in our square root.